Algebra 1, Lesson 22. Part A is a review of numerical and algebraic expressions. So, the meaningful arrangement of numerals and symbols that designate operations will be a numerical expression. It has numbers. Numerical expression. Every numerical expression has a particular value, which that is the number that it represents, what it equals. Okay, so here are a few numerical expressions. And we're going to write their values below here. Here is one numerical expression. Its value is 4. 6 plus 3 is a numerical expression. It's numbers and operation symbols. Add them. Its value is 9. Okay, now here we're getting into more of the order of operations because there are two operations. 2 plus 3 is 5. The value of this is 20 because we multiply 4 times 5. The value of this last expression is going to be 12. When we add what's inside the parentheses, we have, 8 plus 4 is 12. And so what we have now is 7 times 12 divided by 7. The 7's cancel. The value of that is 12. Okay. Now, algebraic expressions include numerical expressions and expressions that have variables. So this is, capitalize that, this is a sentence. Algebraic expressions include numerical expressions, so these technically are algebraic expressions, but also include expressions that have variables in them. Alright, so now we're down here to some other algebraic expressions, and we're going to talk about their value. So, for the first one, it's just an 8. Its value is 8. For all the rest of these, there are variables, and so the value of these expressions depends. It depends on what x is. We don't know unless we find out what x equals. Okay, so that's for all of these. It depends on the value of x. I'm just going to write depends. Okay. So, what if x equals 3? Well, I mean, that's still an 8 no matter what, because it's just 8. If x equals 3, this expression's value is 7. If x equals 3, this expression's value is 3, because that's 9 minus 6. And if x equals 3, this is 21, because you add first in the parentheses, that's 7 times 3. 21. But if x happens to be 1, then we will put a 1 in place of the x. This will be the replacement value. So 1 plus 4. If x equals 1, then that expression is worth 5. And if x equals 1, then this expression, 1 squared is just 1. The value of this expression would then be negative 5. And if x equals 1, this last one will be 1 times 5, so 5 again. Okay, so when it's algebraic, its value depends on the value of the variable. Alright, that's all we should really have to write for part A. For part B, down here at the bottom of this side. Okay, so here's what we're getting, well, really we're getting ready for word problems. We're going to be translating from English into math, basically. So to make statements about quantities, we can use grammatical sentences in English, but we can also use algebraic sentences. Okay, so we have here for the English, the number of peaches equals the number of apples. And so you should use meaningful variables, P for peaches, A for apples. That's the number of peaches equals. Okay, the number of peaches equals the number of apples. Next one, the number of peaches does not equal the number of apples. The number of peaches is greater than the number of apples, and then we have the number of peaches is less than the number of apples. This first one is called an equation because it has an equal sign. All the rest of these are inequalities. Inequality. I should have made that plural because it's for all of them. Okay, each of them is an inequality. They are all inequalities because they're saying not equal in one way or another. That literally says not equal, and if it's greater, it's not equal, and if it's less, it's not equal. Okay, we will do more with translating from English into math later, but for now, that's it. Part C is on the next page in your notes, and this is about conditional equations. Okay, so first, an equation is an algebraic statement consisting of two algebraic expressions connected by an equal sign. It's saying this expression equals this other expression. So, equation. All right, and we're going to use this space to write examples of some equations. Okay, so let's start with something fairly simple. 4 is equal to 3 plus 1. Okay, this is a true equation. You know that 3 plus 1 equals 4, so it is an equation, and it is true. So we're going to write true equation, because they're not always true. Okay, next, this one's a little longer. 4 plus x equals 2 plus x plus 2. It is an equation. Here's an algebraic expression. Over here's another one. They are connected by an equals sign. Is it a true equation? Okay, so we need to compare the two sides. If we add the actual numerals here, add these numbers, 2 plus 2 equals 4. So this side says 4 plus x. This side is equivalent to 4 plus x. They are identical, so this is true. No matter what number you pick for x, if you put it into both places where these x's are, you will get a true equation. And I'll let you do that if you wish. Choose as many different examples as you want. Put the same number in place of both of these x's. It will always be a true equation if you simplify them correctly. Okay, next one. 4 equals 6. This is, I hope, clearly not true. This is a false equation. It has two expressions connected by an equals, but that is not true. This is a false equation. All right, so how about 4 plus x equals 6 plus x? Might it be true now? Again, these represent the same number, and if we're adding 4 to that number on this side, and we're adding 6 to that number over here, this side is always going to be 2 more than that side. So this is not, they do not equal. This is a false equation again. Okay, now, last one that we're going to write is x plus 4 equals 8. That's what we're writing in this part. X plus 4 equals 8. Is this true or is it false? Well, that depends on what x equals. If x equals 4, 4 plus 4 is 8, then it's true. If x is equal to anything else, then it's false. Okay, so this is what we call a conditional. This is a conditional equation. It might be true. It depends on what x equals. So that's actually what we're writing here also. Conditional equation is an equation that's true only under certain conditions. And right here's an example of that. This kind of equation contains variables, and it's only true for certain replacement values, certain values that we could put in to replace the x. In this equation, x would have to be 4 for this to be true, because 4 plus 4 equals 8. Alright, so those replacement values that make the equation true, that cause the equation to be true, they are called roots of the equation, or solutions of the equation. They solve it. We also say that they satisfy the equation. All right, so now we have some questions we need to answer down here. And these are not yes-no questions. They are either-or questions. But sometimes both of these will satisfy the equation. So you must always try both of them. I want to see your work that shows that you tried both of them. So I will be giving you these examples. So we're going to try negative 2 in place of x, and then we're going to try positive 5 in place of x in that equation. So first, negative 2. Put negative 2 in parentheses in place of this x. Negative 2 squared. Does that equal negative 5 times negative 2 minus 6? Well, let's see. Simplify this side. This is a negative times a negative. This is positive 4. Here we have negative times a negative is positive 10 minus 6. Hey, that's 4. 4 equals 4. Okay, simplify this side also. These two match. Negative 2 satisfies that equation. So negative 2 does. I'm just going to write yes. Okay, but now I'm going to try 5. I don't have to write the plus in front of it for a positive. 5 squared equals negative 5 times 5 minus 6. All right, this side gives us 25. These are opposite signs. We're getting negative 25 minus 6. Well, that's not going to equal. These are both negative. That is positive. But I'm going to finish simplifying the right side. That is negative 31. That is not true. The only one of these that satisfy that equation was negative 2. Okay, make sure you write which one, or if it's both of them, and circle it. This one satisfies that equation. Now we're given these same numbers to try. And see, it's worded differently each time, but they all mean the same thing. We had those phrasings up here. Is negative 2 or positive 5 a root of this equation? Okay, same solution, or same replacement set. These are the numbers we're putting in to try. New equation. So let's try negative 2. It's being squared again. So negative 2 in parentheses squared minus 3 times negative 2. We're going to find out if that equals 10. That's 4. Again, negative times a negative. And now we have different ways of looking at this. We can leave that a minus, and then these are opposite signs. So we would get a negative 6. Minus negative is plus a positive. That's 10. That's true. So that one works. We're still trying the other one. Sometimes both of them work. All right, so 5 squared minus 3 times 5. Let's see if that equals 10. 25 minus 15. Okay. Yes, that also works. Both of them work. So we're going to put negative 2 and 5. They both work. They are both solutions of that equation. They are both roots of the equation. All right, we've got one more example here. This one looks a little longer to simplify. Same solution, or keep calling it that, same replacement set, same numbers to try. It might not be the same solution. Okay, so 3 times, okay, in place of x first, we're putting negative 2 squared. Does that equal negative 5 times negative 2 minus, okay, the absolute value of negative 2 is 2. I'm just going to write 2. This part right here is 2. All right, so now we simplify. Exponents before multiplying, so 3 times negative 2 times negative 2 is still 4. Okay, negative times a negative is a positive. 3 times 4 is 12. 10 minus 2 is 8. That doesn't work. Okay, next. 3 times 5 squared minus 5 times 5 minus 2. 5 times 5 is 25. It's still 25. Okay, so we have 75 minus 25. Well, yeah, this will be easier to do, I think, if I don't put those two together. So 75 minus 25 is 50. 50 minus 2 is I forgot to put the equals in there. You did notice that, right? Okay, I was supposed to have an equals right here. I wasn't supposed to simplify that. Be very careful. Okay, so 75, does that equal negative 25 minus 2? So I can't subtract that. There's an equals right there. There we go. 75 equals negative 27. No. There is no solution to this one. Well, I shouldn't say that. There's a solution, but it's not this. Okay, so neither. Just write neither. Usually at least one of them will work in the problem sets for quite some time, but sometimes it's neither. Sometimes it's both. Often it's one of them. So be careful. Don't get in a hurry like I apparently did. Totally forgot my equals. But that's them. That's what we're doing for this part. Have fun.